This video is for section 9.7. We're going to look at some examples now that we know the scale factor or similarity ratio of two similar figures is the same as the ratio of perimeters. So they're telling us the perimeter of triangle RST, that's this little guy here, is 9. So perimeter equals 9 for that little guy. That means these three sides add up to 9. These two triangles are similar. That's really important. Find the value of each variable. Well, we know this 3 is going to go with something over here. We can check our statement to see. Segment NM, that's the one that has like the 3. That goes with segment SR. So these ones go together. But we don't know how long that is. This one's going to go with this one, but we don't know how long this is. This one goes with this one, but we don't know how long that is. So how are we going to find the scale factor? Well, use what you know. You know the perimeter is 9 over here. What's the perimeter here? 3 plus 4.5 plus 6. That gives you 13.5. Now, if you compare the perimeters, 13.5 with 9, that's going to give you the ratio of perimeters reduced. I'm just typing it into my calculator right now. It gives us 3/2. If that's the ratio of the perimeters, it's also your similarity ratio. So what that means is this is a ratio of 3 to 2. So is this. So is this. If the ratio of perimeters is 3 to 2, the similarity ratio is 3 to 2. So 3 to 2 equals 3 to x. 3 to 2 equals 4.5 to z. Three over 2 equals 6 to y. Now we're going to cross multiply in all these cases. Or, obviously, 3 times 1 is 3, 2 times 1 is 2, 3/2 equals 3/2. That's pretty easy. Didn't need to cross multiply there. This one you probably will. 2 times 4.5 is 9. So we're going to multiply there and then divide by 3. 9 divided by 3 is 3. 6 times 2 is 12. 12 divided by 3 is 4. Those are our side lengths. Now we can double check. 2 plus 3 plus 4 equals 9. So that sounds pretty good. Pretty sure this is the same exact type of problem. They're telling us the perimeter of this big triangle is 64. So compare it with the perimeter of this little one, 12 plus 16 plus 20. That equals 48, I think. Compare those. 48 to 64. I'm going to type this in. We're going to see what it equals. 48 divided by 64. Math, enter, enter. That's 3/4. So that means our sides that correspond need to be into that ratio of 3 to 4 as well. So I'm going to say 3/4 equals 3 different ratios. And then I can cross multiply and solve. Now make sure you know what goes with what. This is just a translation and an enlargement. So this does go with this does go with this. But please be careful. Segment GH goes with segment KQ. So 16 does go with A. 12 is going to go with B. 20 is going to go with C. Okay, now we're going to cross multiply. I'm going to do 16 times 4. And then I'm going to divide by 3. And I'm going to get 21.3 repeating, which is 21 1/3. going to cross multiply here. I'm going to do 4 times 12. I'm going to get 48. I'm going to divide that by 3. So B is 16. 4 times 20 is 80. 80 divided by 3 gives you 26.6 forever. That's 2/3. Let's say we have two similar triangles, and the similarity ratio of this triangle to that triangle is something that didn't copy over. I'm going to put a number in there in a second. Find the perimeter of triangle GFR if the perimeter of triangle SLC is 14 inches. So I'm going to say the scale factor is 2 to 5, or the similarity ratio is 2 to 5. So if the similarity ratio is 2 to 5, then the ratio of perimeters is going to be 2 to 5 as well. Since we said it was 2 to 5, the 2 corresponds with the first triangle. So if the perimeter of the first triangle is 14, then you line that 14 up with that 2 in your proportion. And you solve for the perimeter of the bigger shape. Obviously, it's going to be bigger because 5 is bigger than 2. 14 is with the 2. The new perimeter is with the 5, so that's going to be a bigger answer. Okay, 5 times 14, that gives us 70, and then divide by 2. Okay, so the perimeter of the bigger shape is 35 inches. That's how you can figure that out if you know the similarity ratio and you know the perimeter of one of the shapes. This one's the same type of deal. Suppose you have two similar triangles. Triangle PQR is similar to triangle XYZ. And the similarity ratio of triangle PQR to triangle XYZ is some number. I'm going to put it in there in a second. Find the perimeter of triangle PQR if the perimeter of triangle XYZ is 30. Yeah, I'm just making this up. Let's say that the similarity ratio of this triangle to this triangle is 7/3. That means this guy's your big triangle because he goes with the top number. So if you know the similarity ratio, the ratio of perimeters is the same. You know the perimeter of the smaller shape, and it's 30. So what's the perimeter of the bigger shape? If you've been doing your work, you really don't even need to cross multiply at all. I think you know that's 70.